My name is Rodney Kawecki. I do videos on physics, advanced physics, preferably Aristotle, Kepler, Galileo, Newton, Einstein, Edwin Hubble theory. And the video I want to put out today is, I had put an earlier video, 15 years ago, I think, and it had to do with the first book I ever wrote on physics. It was called Supertelic Electromagnetic Gravitational Universe Technology Theory. In short, CGUT. In this video, I'm going to go back to that time, because I've written a number of books on physics and found new discoveries that have not been taken in consideration in physics. That's called lack of information. But anyways, in this video, we're going to talk about E equals MC square. What is E equal MC square? Where does it come from? What does it mean? Well, E equals MC square is energy relative or equal to mass, which is an object, at the speed of light, squared. The squared part means that much energy. The C part is the speed of light. Now, actually it's components, but when Einstein rewrote Newton's theory on F equals ma, which is mass acceleration, and used F instead of E, Einstein took C, or MC square, and riddled it with velocity. So you have, what I'm talking about is you have energy equals C, the component, or the speed of light. Squared is the energy, but there's also V, which is not in there. It should be. It's called C over V. The complications relative to this equation and C over V are how you explain the speed of light relative to Einstein's general relativity. So I'm going to go into what E equals MC square actually means. Now, I have a diagram that I use that illustrates Earth, gravity, and space. Space is actually the lack of gravity. When we look at space or the universe, the system, we're referring to how much mass is in that system. And that's about 5%. They calculated that if you take all the planets and galaxies and put them all into one thing, that mass is about 5% of space, an infinite amount of space. Now, I don't know whether that's where Einstein got the idea that you needed an infinite amount of energy to travel faster than light, but that's where infinite comes into. So we have an equation, E equals MC square, or E equals MC over V square, which are preferably the same thing. And we have Earth. Earth has a gravitational force. Gravity is an interference energy that is mixed in a planet's or Earth's atmosphere that allows momentum to moving objects. Now, like when you jump or something, or you walk, they can calculate that. Newton calculated that force as 9.8 meters a second. Now, 9.8 meters a second is equal to 1 mile a second, for reference. But the gravity of Earth lacks in the vacuum of space. And somehow Einstein believed that they're both the same no matter what. I don't know how he came to that conclusion, even though that was in 1920 or 1915. Nothing can travel faster than the speed of light. So we have an Earth atmosphere that has a gravity force. We have the speed of light as the perimeters from 0 to the speed of light. Now, m is the mass. No matter what the mass, nothing can travel faster than the speed of light, according to relativity. Now, that mass is coordinated with c, which is the speed of light, or v, which is acceleration or velocity. Now, E is the energy. E actually doesn't change. It's there. But in some of his equations, if you look at him, in one of them he puts 1/2 E equals mc squared. And that's where the problem arises. He cut the energy in half relative to the speed of light because of gravity. Because gravity is an attractive force. It's a medium. When we get in a ship and get into flight, we're affected by the Earth's gravity. We're inside the Earth atmosphere. And as we travel, the same amount of energy that we use to accelerate, gravity accelerates its gravitation attraction, and it comes out to about 50%. So when we, instead of being able to travel c, which is the speed of light, we can only travel 93,000 miles a second. Now, the velocity and acceleration are 93 miles a second. Now, in his equations for that, he put 1/2 E equals mc squared, or 1/2 E equals mc over v squared. And well, he shouldn't have did that. That's an error on his part. E never changes. That's the speed of light. Whether you go 10 miles an hour on Earth or 100 or approach the speed of light, which he claims you can't do, you can only go in Earth's atmosphere 93,000 miles a second because of gravity. Now that's half of the speed of light. That's why he put 1/2 E in front of his E equals mc squared equation. So now we're going to go from Earth's atmosphere into space, the vacuum of space. An infinite terrain of empty space, which only 5% of it is matter. Stars, galaxies, planets, systems, star systems, whatever's in it, and everything that is in it. Now, if you look at the scale, 5% of the speed of light is small. It's like 95. It's like 5% of 100, which leaves 95%. Now, on Earth, we can only travel 93,000 miles a second due to gravity. Gravity in the vacuum is less than 5%, actually, but we'll say 5%. So we can travel 95% of the speed of light in space with no problems. There's very little. That's why it's called low density space, because there's not hardly any. There's 5% of it, or less than that, of gravitatoric energy or mass in space. And the 5% of planetary matter or galactic matter is all broken up into pieces: stars, planets, systems that correlate and spin and rotate and are in orbit. Now, to try to make it more clear, the planets and stars orbit and rotate at high velocities. Now, you could ask yourself, well, how could Earth or a planet orbit in such high velocity compared to the Earth? We only travel 5 miles an hour, or 10 miles, or 100 miles an hour. And if we calculate the velocity of planets in their orbit, they're in like 250,000 miles an hour. That's great. And they are big. Well, that's due to the vacuum. That's 95% of the vacuum is considered empty space, dark matter, or dark energy. Dark energy is the sum of some atomic particles that hold matter together, and they are considered a negative energy because they have no mass, or it's so small that it's, like I said, 5% of the universe is energy. If you want to look at it that way, and other physicists believe that the vacuum could be just that, empty, something that seems to be sucking energy out of something else, or anything else, the other 5%. So in the comparison of the two, Earth and space, we have to use Earth as the example because we live on Earth. We know about Earth. We don't know a lot about all the other planets and stars, their sizes, what they're made of, etc. But Earth, we can say we do. We know a lot about that. So on Earth, we can travel 93,000 miles a second. In space, the same ship can travel 95% light speed. That's Einstein's approaching light speed, or 99.99999. We'll consider that with 95% of matter that exists in an infinite region of space, empty space. Now, what I'm saying is the ship on Earth puts out its propulsion. It has the capacity to travel light speed, but it can't because of gravity. The attraction of Earth and its gravitational pull acting on it only allows it to travel half that, which is 93,000 miles a second. Well, in space, it's not how much gravity, it's the lack of gravity. It's only less than 5%. In fact, it's about half of, it's about 51/100ths of 1%. And if you want to get technical about it, which is almost 99.999, as Einstein puts it. So we can travel almost light speed. Let's call it light speed. Warp speed, yes. We can travel in space warp speed, or the speed of light. In Newton's mechanics, it's the same solution or the same outcome. We have Earth at half the speed of light, and in space, because it's empty, vacuum, we have almost the whole speed of light we can travel. But it doesn't end there. Relativity has put an end to it right there. But that's not the case. I'm going to go into that now, why it's not the case. In his equation, E equals mc squared, he put 1/2 energy on the E, mc squared, or c over v squared on Earth, which means 93,000 miles a second. Well, he shouldn't have put the 1/2 there. He should have put it in front of the c or the v squared. But he did put it in front of the E. The E never changes. It's the speed. It's the energy for the speed of light. If it's 1/2, then you can't do it. You can't even travel half. So he put 1/2 there in some of his, as he explained his equations. Now you take that and relate it to space. We have mass, which is less than 5%. And see, on Earth, the ship had the capacity to travel the speed of light. But it can't due to gravity. In space, we have the lack of gravity. In other words, some atomic particles that make up space, if they are subatomic particles, as the Higgs boson and other particles, the layers of space, then it's still negative. We can still travel the speed of light in space. And I showed it. We can, with looking at it, we travel 95%, or in actuality, if you want to do the real math, it's like 5/10 of one compared to 100 over 100, which means 99.999. Okay. Now Einstein, like I said, he put 1/2 on energy. That's not supposed to be there. And what it did, it put 1/2 on space acceleration or velocity. And it's wrong. If on Earth we have the capacity, our engines can travel the speed of light, but they are slowed down by gravity, where in space it's the lack of gravity and we can travel at the speed of light. Well, that 1/2% on E from Earth was taken away on E equals mc squared relative to space travel, or c over v. And if we have the capacity to travel at the speed of light and there's no gravity, then we can travel the speed of light. Since 1/2 E was placed on energy, it's an error. We have the full capacity of E, of the energy. To explain it's kind of hard, but I mean being truthful. It's like being in a spaceship in space, and the acceleration pedal is only at halfway down, and you're traveling the speed of light because there's nothing holding you back. But you still have the full other half of acceleration to use, that much more energy to accelerate. And if you do, what happens? You're going to go 372,000 miles a second, twice the speed of light. And I know why this is to be factual, based on, I go into Edwin Hubble's theory. Now, let me try to go through it again to make it more simple. There's no gravity acting on us. So, if we have the capacity to travel the speed of light, we can do it easily. Because there's nothing pulling us, holding us back. On Earth, there's gravity holding us back. But there's no gravity in space to hold us back. So we accelerate faster and easier through the corridors of space. In between the planets and stars and the systems of stars, the pathway that exists between these large celestial planets and galaxies and all that stuff. So, but if you can understand what I'm saying, is we lose the gravity content in space. There's no gravity. So, if gravity acts on the object like on Earth and slows it down to half, in space, where there is no gravity, we have the capacity of 95 or 99.999 easily. But what are we going to do with all that other energy that we're not using because we have the capacity of light? There's nothing, we don't have to use it. So what it does, it's like extra energy, propulsion actually, energy, that allows us to travel faster in space. Like I said, he should have put that one half, not in front of E, but in front of the C. Where on Earth, due to the gravity force, you only travel 93,000 miles a second. But he put it in front of E, which created a problem. So people think that, well, if it's in front of E, then you can only travel at the speed of light because there's no gravity in space. We're in a vacuum. And that's not it. We still have that extra 50% energy. Excuse me. Now, I've been working on these ideas for years. And if you look at the diagrams I'm putting up and stuff, you could understand more of what I'm talking about. And it was because of this idea that I had that I thought I'd write books about physics back in 1995. I started out. So I've written several books. And in my first book was this idea that I just explained right here.